Hi guys, we are going to look at the unit quiz 7 self quiz. Before I jump into the quiz, I'm just going to go and try to review this chart with you. And I think this is something that's going to be very important. One thing about this chapter is that you're talking about normal approximation. And what is normal approximation? Basically, in summary, we can use the like from, let's say, any random variable from any distribution, whether it's Poisson, exponential, or uniform, can be approximated with the normal distribution if we are taking multiple elements of that sample. So let's say if your sample, if your random variables follow a, I don't know, a Poisson or uniform distribution, and you're taking about, let's say, 25 or multiple of them. So the average usually, could be approximated using the normal approximation. Again, this is due to the, as you saw in the book, in the notion that you learned this week, the central limit theorem. As you take more of a sample from depending on the distribution it comes from, it tends to follow normal distribution. So that's what you're going to see a lot in the quiz, where we have parameters from different distributions like Poisson, uniform, or exponential. But from those parameters, we can calculate probability using normal distribution. So the first thing I want to review is this chart. So I know in the self quiz, this chart, this concept come up a lot. So I think maybe before we start, we're going to refer back to it. I think it's a good thing to maybe look at it first. So what I did here, I look at the normal distribution, and it's just a specific case. You're going to see in the assignment, in the self quiz, you are given the area 0.90. So remember, under the normal curve, the area should be 1 because, again, it's a probability space. So remember, all the elements of a round in the sample space, the probability of all of them should be 1. And in the case of a normal, we can represent this by this bell-shaped curve. And usually, from this bell-shaped curve, let's say we can say, okay, we want to find the distribution, the probability that, like, say, one of the random variables that we have defined fall within this area of 90%. So, and you see this area is bounded by the quantile of 5% and the quantile of 95%. So basically, the quantile of 5% means that this is the score or the z value, so that technically I should have put z instead of q here. I can use q because in your R code, to find this value, you use a q. Like for the case of a normal, you use q norm. And remember, these two values should be asymmetric. What that means is that because this is normal, and usually we expect, in the case of a z, we expect to have the mean to be 0. So it means that whatever value you find here, technically it should be the same value but negative here, because you see the length from here to here is the same length from here to here in general. And the z-score at 5% here just means that this is this at this point, at this z-score, we are above 5% of all the observation in the sample space. And the q 95% here just means that at this point we are above 95% of all the scores of the space. So again, I just want you to have this picture in mind. Again, maybe it might not make sense what I'm saying now, but we're going to look at the quiz and then refer back to it. At the self quiz, I'll refer back to it. So the first question, again, make a recall to population 1.csv, where we have a mean given to us, and yeah. So we have a mean given by this. And what we want to identify here is basically is a simulation that I'm sure that the probability of the sample is falling between, basically within 2 centimeters of the population average. So that's kind of the simulation that need to happen. So here you're saying that is approximately this probability, which is 0.925. So, so in a sense, what is important when you read this is to note what is your mean. Always think about what is my mean and what is my standard deviation. And yeah, so from reading this is what we get. We get the two parameters, and we know that we're supposed to apply the normal approximation. So question 1. Using the normal approximation, the probability that the sample average of height falls within 2 centimeters of the population average. So what I mean is that if the population average is given by 170.035, then we are saying that we want the probability that um, that the average is either this value plus 2 centimeter or this value minus 2 centimeter. So what does that mean? It means that we are looking for the probability within this interval. And so remember, mu minus 2, we know what it is. We just take the value 170, we subtract 2. Mu plus 2, you take 170, you add 2. So all that means is that we remember we know how to find the probability that you are within an interval. You have to use the p norm because you're finding the probability less than, and you subtract. So, and we know because we are using the normal approximation, and what is important in the normal approximation is always to have your parameter mean and standard deviation. So in this case, we know the mean is 170, and we know the sigma, which is the standard deviation, which was already given in the problem, is 1.122. So to find the probability that the average fall within that the sample average fall within 2 centimeters of the population mean, we just do the p norm of 2 plus the mu plus 2, and we use the parameter because it's a normal distribution, and then we subtract the p norm of mu minus 2. Again, remember in the previous video I explained why we have to subtract to find the probability you are within this range, because here you take all the elements, and then from all these elements you find the probability. Basically here you basically find the probability that the sample average is less than mu plus 2. So that means it could be 0 up till mu plus 2. Similarly here, you find the probability that the average height falls, the average height is between 0 and mu minus 2. But you remember mu minus 2 is less than mu plus 2. The probability here should be less than the probability here. So because the probability here also includes some of the elements here, but we only want the probability between mu plus 2 and mu minus 2. So what we do, we remove all the elements that give us a probability that this probability. So that's why you do the subtraction to find that the value is actually 0.9253374. I think by now most of you guys get the hang of why we do the p norm for an interval. So that should be pretty straightforward. If you don't have a question, you can let me know again. Question 2. So question 2 now, using the normal approximation, we get the central region that contain 90% of the distribution of the sample is of this form. So we need to find the z value. So again, we're going to look back at my chart. So the z value here is a quantile. That's basically what they're asking. So basically what we are saying is that the central region is 0.90. So basically you take the central region here, this whole region, because you are dividing this by the fifth percentile, the 0.05 quantile or z-score, and the 0.95 z-score. So basically this question is asking you to find what the z value is, and you can see the z value is actually the q norm of 0.95. And why is it 95? Because we have the value, we break down this one so that 90% fall in this area. So which means that at the upper bound, we are going to have 5% and 5%. You see, if you add all those probability, you end up having 1. So that's why you need to do the Q norm of one of those quantile. And in this case, it was the Q norm of 0.95. But remember, the Q norm of 0.05 is just going to be negative of this value. So that's pretty much